OK. So what did I say? Correct. So what I have here is y equals 4 times cosine of x plus pi over 4 plus 4. So guys, I'm going to do this over and over and over again. So it's like boring for you. Just not like boring the problem, but like me explaining every single one of these points, because you have to know how to go ahead and go through all of these. Thank you. Hello. All right. So every single time we're going to be graphing, we're always going to have to know what the amplitude is, the period, the x scale, the vertical transformation, and the phase shift. All right? We're going to do this for every single type of problem. So you might as well just get used to it and then say, all right, I'm going to have to figure out this information, and then I'll be set to graph. Because just doing the graph is one step. All right? And as you guys mentioned, as you looked at that test review, just knowing what the graph looks like on a graph calculator is one step. You also have to know the important information. So amplitude. Well, first of all, then let's go back. Remember, if you guys remember, cosine is the same thing as the sine, where the a, b, x, c, and d are all going to be labeled. So the period is the absolute value of a, which in this case is absolute value of 4, which is then equal to 4. The period is 2 pi divided by b. In this case, our cosine of x is our coefficient of 1. So therefore, our period is just going to be 2 pi divided by 1, which is 2 pi. Our x scale is 2 pi divided by b divided by 4, which in this case is just going to be 2 pi over 4, which is equal to pi halves, very similar to our last problem. Our vertical transformation is going to be our d, which in this case is 4. So that means we're going to shift the graph 4 units up. And in this case, our phase shift is pi over 4. So therefore, we always take our bx minus c equals 0. In this case, we have x. Remember, this looks like that. Bless you. So therefore, we have x plus pi over 4 equals 0. Subtract pi over 4 from both sides. So therefore, we have x equals pi over 4. Cool? Cool. OK. So now what we need to do is kind of determine where are we going to start. Yes? I don't know. Is that the original problem? Yeah. So then remember, to find the phase shift, you set it equal to 0. OK? So what this is going to tell you is this is going to be our starting position. The total graph is taking a shift to pi over 4. Yes?
So you start at pi over 4, not negative pi?
Like that would be negative pi over 4, so it's subtracted.
Right. So the form is, all right, let's go back to something like this. Let's do y equals x minus 2 squared plus 1. Right? Let's go back to quadratics real quick. This tells you to shift 2 units to the right, correct? Similarly, this, all right, oh, wait. Oh, I'm sorry. Yeah, that is negative. OK, I got what you're saying. Thank you. All right, yes. So you're going to shift pi over 4 to the left. Thank you. Now, remember, that's not always the case. You always have to, it's not like quadratics where you just say, oh, it's pi over 4 to the left. You have to set it equal to 0 because your b, in this case, it's 1, so it doesn't affect it. But your b will affect your phase shift. So you have to always take whatever's inside the function, set equal to 0. All right. So now we grab a nice little long x-axis. And yes, I'm going to want to start at where my phase shift is at. So if the phase shift is at 0, I start at 0. If it's at pi over 4, I'm going to start at pi over 4, or negative pi over 4. So that's going to be my first point, negative pi over 4. Now we look at my x scale. My x scale is pi halves. Now again, what I was talking about is I don't want to be adding pi halves to pi over 4. So let's convert this to 2 pi over 4. It's the exact same thing, right? But, and actually, let's do in the positive direction. It's the exact same thing, but now you're just adding it in terms with the same denominator. And we'll go back and simplify this later. You can just go ahead and see. So the next one, so if I add, so remember, between each x scale, my x scale is 2 pi over 4. That means between each one of these scales, I'm going to add 2 pi over 4. Does everybody understand that? The distance between each scale is 2 pi over 4. So if I have negative pi over 4 plus 2 pi over 4, that means that is pi over 4. This one would be 3 pi over 4, 5 pi over 4, 7 pi over 4, 9 pi over 4, 11 pi over 4, 13 pi over 4. 15 pi over 4. And there's really none of them that I can simplify, right? Now, you don't always have to go and show where exactly the y-axis is, but we know the y-axis is going to be at 0, right? These are positive, negative numbers, so we know my y-axis is going to be somewhere right around here. All right? So that's at 0. Now, we look at our amplitude. Our amplitude is up to 4. That means the highest my graph is going to go is 4, and the lowest my graph is going to go is negative 4. 1, 2, 3, 4. All right? Now, remember, traditionally, the cosine graph would start at 0, right? Well, not really start at 0, but it would intersect at 0, 1. But now my graph has been shifted over pi over 4. So now my starting point is going to be up here. That's going to be the maximum value, right? It used to be right there on the y-axis when I showed you guys the parent graph. Now it starts pi over 4 to the right. The next point is an x-intercept, then the minimum value, then another x-intercept, then another maximum value. Keep on going down to x-intercept, minimum value, up there. And I need to do one more, which would be 17 pi over 4. So now I can just connect these, and I can say, all right, it starts here. And there you go. You guys can see now I have completed 2 complete periods. Everybody see what I did? Questions? Complaints? Constraints? And that's it. So the main important thing, guys, is do this every single time. If you can do this and get this stuff right, this makes it a lot easier. All right. I will tell you, students that struggle with this is they